You are standing at the center of Stonehenge, inside the circle, between the tallest stones. And under your feet, half buried beneath two fallen giants, is a slab almost nobody photographs. It is gray-green. It is nearly 5 meters long. It weighs 6 tons, and it should not be here. For 100 years, the honest answer to Stonehenge was a shrug. We did not know where the stones came from, so we could not ask the next question. That excuse is gone. 3 teams, 3 different techniques, and a follow-up this year that modeled the movement of ice across Britain have traced every major stone on that plain back to the ground it formed in. We finally know. And what we know is worse than not knowing, because the map leads to a question that no amount of chemistry can answer. Why? Start with what we thought we understood. Stonehenge is built from 2 kinds of rock. The giants are called sarsens, a very hard sandstone that forms in scattered blocks across southern England. They weigh around 20 tons each. Some stand 7 meters tall. For centuries, the assumption was simple. They came from somewhere to the north, a day or two's haul. Nobody could say exactly where, and nobody was worried about it. The smaller stones are the bluestones, a dark volcanic rock, and for more than a century we have known they are not local at all. They come from the Preseli Hills of West Wales, 230 kilometers away. That alone made Stonehenge unusual. Mike Parker Pearson, the archaeologist who has spent much of his career on this monument, has put it plainly. Every other megalithic monument in Europe was built from stone, found within roughly 16 kilometers. Stonehenge reached across a country, and then there was the stone at the center, the altar stone as it is called, though nobody knows what it was actually for. It is sandstone, not volcanic rock, but for generations it was filed with the Welsh stones anyway. Same journey, same story. It was not. When the geologists Richard Bevins and Rob Ixer looked at thin slices of the altar stone under the microscope, the minerals were wrong. They did not match the Welsh sandstones. They did not match anything in southern Britain. The one stone lying at the exact heart of the monument had no home. Meanwhile, the rest of the monument was being solved. A team led by David Nash at the University of Brighton got hold of a cylinder of rock drilled out of one of the great uprights during a repair in the middle of the last century, kept in a private collection abroad for 60 years, then quietly returned. They were allowed to destroy part of it. They measured 22 trace elements in that core and compared the result against sarsen from 20 sites across southern England. One site matched. West Woods, 25 kilometers north. 50 of the 52 surviving sarsens share that chemistry. 2 do not match anything tested, and nobody yet knows where they came from. So the outer ring was solved. The inner ring was solved down to the specific Welsh outcrops. Only the heart was missing, and the search for it had to leave southern Britain altogether. To understand why that one stone broke the picture, we have to go to a laboratory on the far side of the world, in Perth, Australia, and to a doctoral student counting grains of sand. His name is Anthony Clarke. He was a PhD student at Curtin University, working with Christopher Kirkland, a specialist in dating minerals, and with Richard Bevins, the geologist who had already proved the altar stone was not Welsh. The method they used sounds almost too simple to work. Sandstone is the ground-up remains of older rock, mountains worn down by water and wind and washed into a basin where the grains settle and harden. Each of those grains was once part of something older, and some of them, tiny crystals no wider than a hair, contain radioactive elements that decay at a known rate. So a laboratory can read the age of the rock each grain was eroded from. Do that for 1 grain, and you have a number. Do it for a few hundred, and you have a pattern, a spread of ages that is specific to the place where the sand was laid down. Every sedimentary basin on Earth has its own. It is a barcode for a landscape. So they read the barcode of the altar stone, and then they compared it to the barcodes of sandstones from across Britain and Ireland. Wales failed. Western England failed. The Midlands failed. The match, the only convincing match in the entire British Isles, was a region called the Orcadian Basin, a band of ancient red sandstone along the far northeastern coast of Scotland. Caithness, Orkney, the Moray coast, about as far from Salisbury Plain as you can get without leaving the British mainland, more than 700 kilometres. Clarke's own position, once the result held up, was that the evidence pointed to a deliberate, carefully planned movement across difficult terrain. Not chance. A decision. The field did not simply accept that. It could not, because there was a serious alternative waiting, and it was not a fringe idea. Ice. During the last glacial period, sheets of ice several kilometers thick ground their way across Britain, and ice moves boulders. Geologists find Scottish rocks scattered across northern England, dropped when the glaciers melted. If a glacier had carried the altar stone south, then the builders had simply found it lying there. No planning, no journey, no mystery at all. That objection had to be answered with data. First, the team tested the standing stones of Stennis and Brodgar on the main island of Orkney. They did not match. The signal pointed more tightly at Caithness, the mainland tip. The sarsens story, meanwhile, was being argued over too. Another group reanalyzed Nash's chemistry and questioned his method. Nash answered, "That is what this field looks like from the inside." Not a verdict. An argument conducted in public with numbers. So here is where we stand. We know where the sarsens came from. We know where the bluestones came from. And the stone at the heart of the monument points 700 kilometers north. Either a glacier carried it, or people did. And here is where it gets strange. Answering that question does not end the mystery. It starts it. Earlier this year, Clarke and Kirkland published the ice test. They rebuilt in a computer the great ice sheet that covered Britain and Ireland at its largest extent tens of thousands of years ago, and traced where it flowed and where it stopped. Salisbury Plain was never under ice. There is no pathway by which a glacier could have carried a block from Caithness to the place where Stonehenge stands. The most generous version of the ice story is this. A glacier might have carried the stone as far as Dogger Bank, now seafloor under the North Sea, but dry land during the Ice Age. That would cut the distance nearly in half. But Dogger Bank drowned thousands of years before the first ditch was dug at Stonehenge. So even then, someone would have had to find the stone, move it before the sea took it, and haul it the remaining 400 kilometers to the plain. 400 kilometers minimum, 700 most likely. 6 tons of sandstone, without wheels, without metal, without draft horses. The team's conclusion is that it was moved in stages, over land where it had to be, by river and coast where it could be. And that is feasible. We know it is, because the bluestones were already being hauled 230 kilometers from Wales by the same kind of society. And at the Welsh outcrops, Parker Pearson's team has excavated what they interpret as the actual quarry faces. So the how is not the problem. Human beings can move a 6-ton stone a very long way if they decide it matters enough. The problem is the deciding. Why this stone? Why from there? Why to the center? There are 2 serious answers on the table and 1 honest dissent. The first answer is that the stones were chosen for where they came from, not for how big they were. That Stonehenge was never primarily an observatory or a temple, but an assembly of places, a monument built out of Britain itself, with each region represented by a piece of its own ground. Parker Pearson has argued for years that this was a monument of unification, and there is evidence that it was not only stone that traveled. In the early decades of the last century, excavators recovered the cremated remains of dozens of people from the ring of pits just inside the bank. A team led by Christoph Snook measured an element called strontium in those burnt bones. Strontium is absorbed from food, and its chemical signature varies with the local geology. So bone carries a record of where a person spent roughly the last 10 years of their life. Of 25 individuals tested, at least 10 had not lived on the chalk around Stonehenge. Their signature pointed west, most plausibly to Wales, and the carbon in the bone showed that some had been burned on wood from dense woodland, the kind that grew in Wales, not on the open chalk. They were cremated somewhere else, and then they were carried to the plain and buried among the stones that had made the same journey. The second answer is inheritance. That the bluestones and perhaps the altar stone were not quarried for Stonehenge at all, but had stood in older monuments elsewhere, which were dismantled and carried south. Several bluestones have carved joints that serve no purpose where they now stand, as if cut for some earlier structure. Parker Pearson's team has proposed a site in the Preseli Hills, Wan Mon, as a dismantled circle that may have been the source. On that point, the evidence is thin and the argument is live. The geologist Brian John has published a detailed rebuttal pointing to scattered radiocarbon dates and the absence of convincing stone sockets. It may be a dismantled circle. It may be nothing of the kind. And the descent. A minority of Earth scientists still hold that the bluestones, at least, could be boulders left by ice that the builders found near the plain. The quarry evidence and the ice modeling have pushed that view to the margins, but it has not vanished. None of this is settled by decree. Now, consider what each answer would mean. If the first is right, then 5,000 years ago, people at the southern end of Britain and people at its far northern tip knew of each other, valued each other, and shared a project. There were already hints. The great stone circles on Orkney were standing by the time Stonehenge began, and styles of pottery spread between the two regions. But a 6-ton stone carried from one end of the island to the exact center of the other is not a hint. It is a statement of identity on a scale that nothing else in the record shows. It would mean a kind of unity across an entire island, in a world without writing, without cities, without a single name we know. If the second is right, then Stonehenge is a relocated ancestry, and its meaning was never about the sky. It was about who you came from. This is the point where the viral versions of this story reach for something bigger. Stonehenge as a lunar computer. Stonehenge as a machine that produced trance-inducing sound. The real research exists, and it is quieter. The idea that the 56 pits encode a lunar cycle is a genuine hypothesis, proposed decades ago by the astronomer Gerald Hawkins, debated ever since, never accepted. The acoustics have been measured properly by the engineer Trevor Cox at the University of Salford, who built a model of the complete monument at 1/12th scale and tested it the way you would test a concert hall. Sound inside the finished circle lingered for about 2/3 of a second, roughly what you get in a living room. Voices were a little louder inside and almost inaudible outside. No echoes, no hidden frequencies. Cox himself has said he thinks it unlikely the circle was designed for sound at all. The real numbers are smaller than the viral ones, and they are stranger because they leave the real question standing. Here is where the search ends. The altar stone came from Caithness. Ice did not carry it. People did, the length of Britain, and laid it at the center of the most ambitious monument in prehistoric Europe. Every major stone now has a home. The question we asked for a century is answered, and that is what made it worse. Because the moment the geochemistry closed the question of where, It opened the question we had been hiding behind it. Not how the stones were moved. We can see how. Why a block of red sandstone from the far north was worth moving at all. Why it, and not a stone from a day's walk away? Why the center? The best answer we have is that the place was the point. That the stone was not a building material. It was a representative. And if that is true, the people who carried it were not solving an engineering problem. They were making a claim about who belonged to whom across an entire island, in a language we can now only read through chemistry. For 100 years, not knowing protected us. It let Stonehenge remain a problem about ropes and ramps. The geochemistry took that away. What it left behind is a question about people. What a piece of the far north meant to them, and what kind of world they lived in where that meaning was worth carrying 700 kilometers by hand. If you had to choose a single stone from the ground where you live and carry it to the center of the world, which stone would it be? And what would you be trying to say? We know where every stone at Stonehenge came from. We still do not know what that knowledge meant to the people who carried them. And it turns out that was always the real question.